This is lesson 11.6, special binomial product. So we multiplied all different kinds of polynomials in 11.5. We're going to be doing the same, but we're going to kind of show you some shortcuts on some special cases. That's what this is all about. So we've got two different special cases that are going to be represented here. The first one looks like this. These are perfect square trinomials. Now you might say, well, that's not a trinomial, but that's going to be the result, is going to be a trinomial. And you can see it's something squared, and it either has a minus or a plus. Okay, and what's going to end up happening is when we say perfect square, it's because 15 is going to get squared, and we know what that number is. Okay, that's 225. And it's going to set up this specific equation. So if I have a plus b, so x minus 15, or x plus 15, I should say, squared, my final answer is going to look like this. So let's examine this for a second. We're going to have a squared, so we're going to end up having x squared in the front. So I'm going to go ahead and put this down here. We're going to have x squared. According to this rule here, we're going to have 2 times a times b. So a here is just 1. So 2 times 1 times b. This is b, so times 15. So according to that, we're going to have a plus 30. And this term in the middle is going to have just an x on it. And then here at the end, we're going to have this b squared. And so 15 squared is 225. So according to this rule, I can get straight to this. Well, how about this next one? According to this rule, I'm going to get a squared. Okay, so 1 squared. And that's going to go in front of x squared. If there was a number there like 4, it actually would be 4 squared. I have 16x squared. So it's not just talking about the x getting squared. It's talking about the coefficient. The next term will have an x. Okay, this comes from minus 2 times a times b. So minus 2 times 1 times 15. So negative 30x. And then plus b squared again. Negative 15 squared is positive 225. So that's going to be my final answer. And then this last kind you can see is very similar, but it's x plus 15 times x minus 19. So the difference of two squares. So when we get this, our final answer is just going to be whatever this is squared. So that's 1 squared, which is just 1. It's going to be looking like this. And then the next part of your term here is going to be a minus whatever y is, so 15 squared, and that's 225. So these are all going to become this, and you kind of start to memorize that. And when you see these perfect squares or difference of two squares, especially as you get to Algebra 2 and higher levels, it'll almost be expected that you're not going to sit there and actually do all the work. You're going to go straight from here to here. So we know how to get from here to here, right? It's x times x, which is x squared. It's x times this, which is negative 15x. It's this times this, which is 15x. It's this times this, which is negative 225. Well, take a look. Negative 15, positive 15 cancel. And what am I left with? This. X squared minus 225. So the long way is fine. It always is going to get us to where we need to go. But these are special cases that when we see them and we use them, we can use this rule to just jump to this. So basically, I know I'm going to end up with a positive 15x and a negative 15x. They're going to cancel. I know I'm going to have an x times x is x squared. I know I'm going to have a 15 times a negative 15, so it's negative 225. So special case. What about these? So we know anything squared means times itself. So this is actually x minus 15 times x minus 15. That's what x minus 15 squared actually represents. So it's going to become this. Let's actually do the work. X times x is x squared. X times this is negative 15x. This is another negative 15x. And this is a positive 225. So you can see in this case, because it's not a positive and a negative, it's a negative and a negative, each time this negative 15 gets multiplied by an x. So I end up with two negative 15x's. So that's why you add them together to get the negative 30x. Plus 225 is here, x squared is here. So we end up where we're supposed to. In here, times itself, it's x plus 15. So similarly to this, of course, you're going to have x times x is x squared. but then you're going to have a 15x and another 15x. That's why it's a 30x automatically. So here's my x squared, here's one 15x, here's another 15x, and then you get a 225. So this and this go together, and this is our final answer. So it will now be acceptable to understand that you can go from here to here, but it's still okay to do it the long way. Either way is fine. But from
Mr.
here
Rockwood,
to here,
please call 4540. Mr. Rockwood, 4540, please.
Apologize for that. From here to here, we no longer have to show this work on these specific types of problems. If you memorize that, taking this number and doubling it, and it's a plus because this is a plus, this number and doubling it, it's a minus, and then just squaring the number and putting it on the end. Okay, it's going to speed some things up. All right, example number 2, we're going to use this now in an actual problem. The side length of a square is this. So what we know about a square is that all the sides are the same. That's why it's a square. So it's 7x plus 5, and so is this side. 7x plus 5. So is this side. That's what makes it a square. And you know what? The bottom of it too is 7x plus 5. So what's the area of the square? Well, we know that area is length times width. Well, in a square, you're multiplying something by itself. Okay, so area is 7x plus 5 times 7x plus 5, which you could rewrite if you wanted to as 7x plus 5 squared. So let's try and use the rule and go straight to the final answer, and then we'll do the work and make sure it's correct. So again, according to this up here, I can shortcut this a little bit. So I know that this squared, a squared, is going to go in the front. So this should be 49x squared. I'm going to add this one twice. And times, oh, I'm sorry, I don't just add it twice. I got to multiply it times a, right? And times it by 2. So right here, I'm going to multiply it. 2 times a times b. So I'm multiplying 7 and 5 together. That's 35. And then timesing it by 2. So that's 70x. So it's this squared here. It's this times 2 here. And then on the end, it's just this squared. So 25. Let's test it out now. So let's do the problem the long way and see if we've actually completed this correctly. Because it's great if that speeds up the process, but only if we're getting it right, not if we're getting it wrong. So multiply here, 49x squared, there's that piece. Multiply here, that's 35x. You can see why. So what did we do over here? We did 5 times 7. So here's the first 5 times 7. Now here's another 5 times 7. So another 35x. And this is why we times it by 2. And then it's 5 times 5 on the end, and that is 25. These two go together, and we make this. Okay, so when we have something squared, we can learn this little shortcut rule to get us to here without having to expand it all together. All right, so that's kind of cool. All right, and then let's use this one other way. So we're going to calculate this without a calculator. So 103 squared. You're like, yeah, right, I'm not doing that in my head. And I don't really want to sit there and do long multiplication, 103 times 103, bring it down, carry over, all of that stuff. So here's what we're going to do. We're going to break this into numbers that we can work with. So 103. Okay, so we've just changed 103, the number, into 100 plus 3, the expression, and we're still squaring it. Now let's go ahead and use this rule. All right, if we're using this rule, the first part, if we have something plus something and it's squared, it's going to be this number squared. And notice there's no x's or variables to tag along, so this is just numbers. So it's going to be this number squared. So we'd have to know what is 100 times 100. Well, the cool thing when you're timesing by things by powers of 10 is you just count the zeros and add them on. So 100 times 100 is just 4 zeros, 10,000. Okay. Plus, now this middle part, 2 times a times b. So you're multiplying these together and then timesing it by 2. So 3 times 100 is 300, times 2 is 600. and then squaring that, 9. So put those together, that should be 10,609. Did we do that correctly? So let's go ahead and check. 103 squared is 10,609. So it's kind of taking this little rule and kind of giving it a different viewpoint, something that you could actually use to do some quick mental math. All right, but the main focus here is simplifying these expressions with a little bit of speed, not having to expand it. But again, it is okay to go through the expansion. But when you do, I want you to go back and start to understand why this is creating this, and it will help you start to make that jump.